like? What were the signs like? What was the activity like? But if you look at a map, it's about 3 lines crossing paper space. It's like, what does that even look like? If you didn't know Times Square was there, how could you tell that was Times Square on a map, besides the label? Everyone has this problem. It's not just Google. I work for a mapping company. We have the same issue. It's a bunch of lines, and you don't know that's Times Square, right? Same thing with the Haight Street situation. This is a good time to introduce myself. My name is Lou Huang. I am the lead developer of a project called Tangram Play at Mapzen. You see a screenshot of this up there, and if you're here for the Tangram demo, that will come kind of near the second half of my talk. My background is also in urban planning and architecture, which is where a lot of the first half of this talk is coming from. So how did we get here, right? And it's with lines. We draw our map with lines. Lines have been around for a very, very long time. We walk through grass, we draw desired lines. We make trails through brush to create trade routes. We build the interstate highway system. We draw all of these with lines. And lines is really, really good for saying, okay, here's how you connect point A to point B. And lines are great. So my colleague Geraldine Sarmiento wrote a fantastic, beautiful blog post about lines and how important they are to cartography and what they're used for. So nothing bad with lines, but here's what happens. You draw a line from point A to point B. You say, get me there as quickly as possible using the fastest, easiest route. So what happens in the middle? Do you care? You just go right past it, right? Douglas Adams had this to say about this, which I thought was really good, from Hitchhiker's Guide to the Galaxy. He said, bypasses are devices that allow people to dash from point A to point B very fast, while other people dash from point B to point A very fast. People living at point C, being directly in between, are given to wonder what's so great about point A, that so many people from point B are so keen to get there, and what's so great about point B that people from point A are so keen to get there. They often wish that people would just once and for all work out where the hell they wanted to be. So this has actually a kind of an effect on the way we build roads. This is a slide from an organization called Strong Towns. This is what they call STROAD, a combination between a high-capacity road and a local downtown street. It's become over-optimized. The idea is that it doesn't matter what this place is. You just want to get through it as quickly as possible to get to point B. In other words, the road network is a series of tubes. And this actually creates a lot of problems. If you say, we want to improve the street, we want to add a bike lane, we want to add some more trees, we want to add parking, we want to make some changes to that street, a lot of people can get very, very angry about that. Why is that? It's because you think this network somehow is losing capacity, not this space is being improved. There's this idea in art that the image of a thing is not really the same as the reality of a thing. And a similar idea in cartography, that the map is not the territory, right? There's a French philosopher named Jean Baudrillard, and he had this idea that when we have these images, these depictions of things, they're so cheap and easy to reproduce that eventually that's all we have. Right? Does that sound familiar in the digital age? So that's kind of our maps. They're so easy and cheap to replicate, those maps become our reality, right? So what I propose is that we have a different way of visualizing what that reality is. We're using lines right now, but what if we could show those maps using volumes, 2-dimensional space and 3-dimensional space? Why would we care? Why would we want to do that? This, for example, if you didn't know how wide the street was, you might not fit a truck down it. Or let's say you take walking directions. This is Justin Herman Plaza, again in San Francisco, where I'm from. This is a bit of a contrived example because you would never actually put this into Google Maps. But it says if you want to get from the bus stop in the lower right to the fountain on the upper middle there, which route do you take? You can take this blue one that they've highlighted. It takes you 2 minutes. They have a couple of alternate routes, also 2 minutes. Which one would you take? Which route do you want to pick? I mean, you could kind of just walk right across it. Those paths don't exist. Another way of thinking about this is in video games. It's fantastic. This is kind of a few years old now, but it's a game called Deus Ex. It takes place in a futuristic, post-apocalyptic Detroit. And this is where we are in the middle of this game world. It's the intersection between two streets. You can kind of see right there in the corner, wayfinding pylon. And if you get up close to it, you see the in-game map. This is what it looks like. What does the street look like? Is that two lines crossing each other? It's actually the volume of that game environment. And it actually mimics the way you think about that space. You can move freely within it. You're not locked to what those lines are. This is not a new concept. So urban designers have been doing this for a very long time. This is a map drawn in the 17th or 18th century, 1748. That's the year. By an architect named Giambattista Nolli. It's one of the most well-known maps of Rome from that time period, and one of the most well-known examples of a figure ground map, showing where the buildings are and the space between those buildings. What's actually interesting about this is that this is showing all public space. So this isn't making a distinction between exterior and interior space. Some of the interior spaces, like churches, are also shown, and they're just rooms connected to the corridors of the roads in between the buildings. This is a series of interconnected rooms. And architects will also draw rooms visualizing space. And similarly, urban designers today show those streets in this kind of detail. They show parking lots and trees and the little roundabout thing. You might not necessarily get that in a digital map. For instance, OpenStreetMap today, this is what this intersection looks like. This is Hammerlandstrasse in Hamburg, Germany. And I just picked it because there's actually a proposal in OpenStreetMap in the community right now to draw streets as areas instead of lines. So they chose this very, very complicated intersection. I'm going to compare this with an aerial. This is what it looks like right now. So you can kind of see the difference between what it looks like in reality versus the lines, which you can also see kind of very lightly ghosted over there. Some roads have multiple lanes. They're very wide. Some are very skinny. Some have turn lanes. Some have medians. Some don't. If you go back and look at this, you see the medians that are drawn in, but the lines that represent that street just create that awkward gap between the medians and what the lines of the street is. So this proposal, and this is the link right there, is saying, here's how we should draw that space. We should draw what the actual dimensions of that street is. We should mark out where the medians are. We should mark out where the dividers are. We should mark out where the intersection space is. They even have things in there for special areas for buses and parking. But the lines remain important, right? Why do we need that? It's for routing, for example. That's how you know how to get from point A to point B. So we can't lose that. And what's even cool about this is that for very complex intersections like this one, you can actually draw in extra lines between new nodes to make that routing calculation even easier. And this is lines you probably wouldn't draw normally because you don't want the rendering of this intersection to be even more complicated than it already is. But now you can do that because it doesn't matter. You've already drawn the areas. And this is a mock-up that they've created to show how you might potentially render that intersection. So this seems super hard, right? I mean, it's a 4 or 5 year old at least proposal in OpenStreetMap. They're nowhere close to getting it implemented. So clearly this is impossible. No one's ever done it. Actually, that's not true. Google's done it in Tokyo. So if you zoom in close enough on a map of Tokyo, you actually can see it's very, very faint on this screen, but you see the edges of the curbs. And that actually kind of works out for Japan because of the way they have their addressing system. It's very different than how we do it in the United States or in most Western nations. Instead of saying, I live on 123 Main Street, for example, a lot of streets don't even have names. What they say is something like the equivalent of saying, I live at building number 4 on block number 8 in neighborhood 12 in Ward 16. And as a result, the entire system, the way they define land, is based on space rather than lines. And so that data exists, like almost everywhere in Japan. It also actually does exist in the United States. This is imagery from the geodatabase used internally by Washington, D.C. So you can see the curb lines, you can see the buildings, the medians, even cuts where driveways exist. Here in Raleigh as well. I looked this up earlier this week just to see if Raleigh had it. And they do. This information is here. You can see this is the shape of the block right around this convention center. I tried downloading it, and I got this message. It was kind of unfortunate. It didn't work. But then through the magic of Twitter, literally having the right people in the room. So shout out to John Gravoy and Dan Fenton from Esri and people from the Raleigh, Open Data Raleigh and Wake County government. Helped me figure out what the issues in the data set got downloaded. Another good example is Austin, Texas. They have fantastic data. You can get not just streets, but you can also get driveways, all the paved areas, every parking lot in Austin if you wanted it. You can get that. Some other places, they'll just charge you for that data. So it's not quite open yet, not everywhere. So I have been starting to collect this information from various municipalities wherever I can find it. So I have a link. This is to a wiki that I have in a repository. So if you are from somewhere or you know somebody who has this sort of data, feel free to let me know, contribute it to the wiki. It's pretty US-centric right now, but this is not a US-centric project. And one of the things about this is that there's no standard on what people call this. So planimetric data being kind of like the overarching umbrella term that people use to call it. But people also call it road casings, curb edges, edge of pavement, roadbed, roadway area, right-of-way, double-line streets. You kind of have to search for all of this just to make sure a place doesn't have this information. All right, so let's do a thing. Philadelphia experiment. So I downloaded the curblines from the city of Philadelphia, not for any particular technical reason. I'm not saying that they have the best data or whatever, but it is the data that I am the most familiar with in my former professional career as an urban planner. So I decided to download it and see what happens. Converted the shapefile to GeoJSON, and now let's try to get this in to Tangram. Let's try to switch over. All right, live demo time. This can't go wrong, right? Let's try this. Cool. All right, so here we are in Philadelphia. What I'm going to do is get a base map in there. About that. Let's get rid of all of that. All right, there it is. So I'm going to add in another source for the GeoJSON file that I have. I'm hosting it locally. What am I missing? All right, I'm missing something. This is what happens when I try to do it from memory. All right. We'll just load the one I saved beforehand. So there it is. Those are the GeoJSON that I loaded from Philadelphia. The interesting thing that we noticed when we loaded this in was that some of the lines were getting rendered twice. I don't know if it's as obvious in this. But that's basically what is happening. So we can filter this if we wanted to. So internally, the F code is just a thing that the city of Philadelphia is calling the polygons. It turns out they have two sets of polygons. They have polygons representing the block, and they have polygons representing the roadbed. Is that filtering correctly? Doesn't appear that it is. Let's actually make this level higher. There we go. So we only have one set of lines in here right now. I also need to put an order on this. That'll work, right? There we go. Kind of, sort of. Okay, so it turns out what I've colored here are the interior polygons. I could also do the opposite and color the roadbed. It actually turns out, long story short, that coloring the roadbed like this is a way better option than having the block faces colored in. And what basically it does the same thing that the OpenStreetMap proposal does, is you show the area of it, and then you mask the lines that are used for regular streets. So 15 minutes left, so do I want to show something else? Yes, I'm going to show so this is the one where I did a bunch of work on it beforehand to make it look like it's part of this style. So this is a map style that's used by Mapzen for our Android app called Eraser Map. And normally what happens is, this is what the roads look like. And if you keep zooming in, you see that problem of the lines showing up. But because on this one I've turned on the roadways, it switches over once you get closer enough to see that amount of detail. And it's actually really remarkable to see the difference, because if I'm down here, for example, like this area right here, is Old City, Philadelphia. I'm going to zoom in on it. It's kind of a weird shape. But if you zoom out, you have no idea that that's what that's like. And when you zoom in, it gets a little better. The Philadelphia curb set also has information about like the ordering of roads. So once you get over here, there's underpasses and overpasses and things. I've not quite figured out how to address those yet, but we do have ordering information that we can use. The other thing that's happened is that once we're in Philadelphia and we've traded out the road network for the shapes, you go to nearby Camden, and that data no longer exists. So we'll have to figure out some way of making that data coexist at the same time. All right. Okay, back to the slides. All right, so this was just the F code. This is information from the Philadelphia curb set. They had some of this in metadata, and then we had to infer the rest of it. So yeah, next steps. So I've shown some of the issues that we had in our demo, right? The transitions between different municipalities, what happens at those boundaries. A way to deal with z-index ordering of streets, what happens when a street is lower, what happens when the street is higher. How to get that pipeline of data from those data sources to the vector tiles that are powering our maps. Maybe it's a supplementary vector tile source. Maybe it doesn't belong in the normal vector tiles because it's too much detail. Maybe it needs to be a second set of information that gets pulled in when you need it. And then the final thing is standardization. Right? So I've talked about how different cities call that different things. So there's not even a common name for it, but the data isn't always uniformly the same either. So sometimes you have lines. Great. But sometimes the lines are not actually continuous. They look continuous, but they're not. They actually get broken up. Sometimes they're broken up because they actually indicate curb cuts. This is where driveways are, and this is where like wheelchair ramps and access points are. So what happens then? Right? Sometimes what you have are polygons, and it's the interior block face of the polygon. Sometimes it's a roadbed. Sometimes you don't actually have any of that at all, but what you have is some other supplementary information like sidewalks, which you can then use to infer the edges of the roads. And then the holy grail is if they actually chunk up the roadways in each leg of the road and where the intersections are. So New York City is the only place I found who actually has that information that you can download in this format, but then has none of the metadata. So there's no way for me to know the difference between one shape and another. Open addresses is a completely separate project. It's nothing to do with this. The guy who's giving a talk about this is one room over in the session after mine. But what he's done is take data sets from municipalities all over the world, arbitrary data sets of address information, and then create a pipeline for collecting all of that into a single data set. So it's kind of like model for can we do all of this into one thing. All right. So talked a little bit about how to get that information into the base map. We know we can do it, but here's some of the future forward-thinking reasons why this stuff matters. All right. So streetfight is a hashtag that was invented by the former commissioner of the DOT in New York City, Jeanette Sadik-Khan, and for the last few years under the Bloomberg administration, spent a lot of time doing streetscape improvements. So this is actually in Paris. It's not New York City, but this is like a very, very wide sort of plaza. What they've started recently doing is proposing extending the curb lines and returning about 50% of the space back to pedestrian space. And here's like a rendering of what that looks like. I can't actually remember where this is, but this is the kind of stuff that people are working on, is returning the space back to pedestrian space, but doing it in a way that's very, very quick and easy. And the way that happens is that these curb lines are fake curb lines. They're just paint on the ground and other paint that mark this space is for a plaza, this space is for a bike. So you're not actually having to do all the capital infrastructure costs of raising the sidewalk. Here's another example of turning what's mostly asphalt into other kinds of space. And another one. And the reason why this is important is because, and traffic engineers know this, is that the width of a lane is directly correlated to how fast someone is going to feel comfortable traveling on it, right? And that translates into public health issues. That translates into economic development implications. If you're getting hit by a car as a pedestrian at 30 miles per hour, you have a 75% chance of surviving that impact. If that car is driving at 40 miles per hour, you have a 75% chance of not surviving that impact. It's just 10 miles per hour for the car, but it's life or death for people, right? And the way you plan out the roads can make that difference. Economic development is the same way. We were talking about stroads earlier, the combination of high-capacity roads and city streets. And Chuck Marone, who runs Strong Towns, likes to say that if you drive somewhere between 30 miles per hour and 50 miles per hour, look around you and figure out why that is. Because you're not driving fast enough for your traffic to be efficient, but you're not traveling slow enough for your presence being in that area to be economically captured. You know, so you're not going to stop and shop there. You're not going to stop and hang out there. Another way to think about this that I really like is called sneckdown. This is a hashtag that you'll only see probably in the Northeast. And this is when, after a snow, there's only enough road that's cleared away for cars to get through. So it essentially proves that you have all this space that doesn't actually need to exist for cars to get by. Again, over-engineered streets. So you can actually draw these lines and say, oh, this could be a wider sidewalk. This could be a pedestrian refuge. This could be a more public space. This is a screenshot from Mapillary, which is an open, kind of like the open source version of Google Street View. They crowdsource imagery, and then they geo-references to actual streets. And what you can see is that there's these images that people take showing where the snow edges stop and where the asphalt begins. And you could, theoretically, use computers to figure out where these lines are in space. And now you have a way of saying, this is really how much curbs we actually need. And then create some change. So to recap, on the left, OpenStreetMap now, where we would like to be in the future. Where we are now, pipes, series of tubes. But what if you think about streets as rooms, right? So similarly, this is it in public space. So final quote. from Project for Public Spaces. If you plan cities for cars and traffic, you get cars and traffic. If you plan for people and places, you get people and places. All right, so everything we do is open. The demo that I just showed with Tangram is in this repository here. And I have another repository which is just words and thoughts and links. And then the wiki page that I have for municipal data is in here. So please take a look and contribute. This is me. I work for Mapzen. And now a word from our sponsors, or Mapzen, would like me to announce. We just launched, in partnership with Amazon Web Services, our elevation tiles. So again, public space, environment stuff, but this is working live now, and this is actual data, and you can use it as a raster tile layer in your maps today. And finally, don't forget to rate me on YouTube. I mean, the Phosphor G website. Thanks. What's that? Oh, okay. I got 6 minutes for questions. Yep.
So for like the data pipelining and that, how do you begin to even solve that if like every municipality has their own schema, their own geometries are all super weird? Do you go to them, or do you just like bring it in-house and have like garbage men and every day they're cleaning up geometry?
Yeah, that's a great question. I imagine we start with the ones that are easy and then try to work with the people who have hard data. I really do believe in like making partnerships with people within government who supply that data. I don't really believe in that the right way to do it is to ingest data but never give back. So hopefully the data quality becomes even across the board. Oh, you have a question? Okay, hi. Okay. Yeah. Have I considered lane lines? I have considered lane lines. There's no reason why we wouldn't do lane lines. We could do lane lines. Oh,
So you seem to outline the standardization as a big challenge. Who's leading the semantic definitions for your perfect case, or
yeah.
where's the leadership on that, and how can that cycle back to municipalities or people that actually are collecting that data so they get it in your best case if that's where
Right.
the community wants to
Right.
go?
Right. So the question is, who's leading the leadership for developing the standards? I guess it's me. I don't know. Yeah, I don't know who else is out there talking a whole lot about this, but I would like to see it happen. So maybe I can convince someone else to do it, or maybe it's me. Yep. Back there.
So I just follow up on the other one. How do you reach out to cities to say like, hey, you have sidewalks, but really it'd be better if you had, just like building pad areas or something like that?
Yeah.
How do you start that conversation and kind of get them involved in changing their data?
Yeah. Okay. The question was, how do you get involved with the city GIS people and talk to the people within cities? I've talked to a bunch of people within cities on other things before. There are a lot of people at different cities who are here now at this conference. There are a lot of people who are very active on Twitter and who want to be part of this community or part of the community that works with this data. And again, it comes to like, who's willing to, who has people who are willing to talk. And maybe not everyone will. Maybe Nashville will forever charge $500 for a CD of data, but we don't start there, right? But we can talk to people in Raleigh and New York and Philadelphia, and we can start there. There's a person at Code for America, he used to have this analogy. I actually don't think he made it up. The analogy of like a lot of people within government just sort of sitting on an ice floe like penguins, waiting for someone else to go first. And the minute someone else goes first, everyone else follows. John? Yeah, the question is, where does that data even come from? How does it get collected? From what I can tell, like the cities actually just pay people to trace aerials. There are people who create this data and say, hey, you know, there might be tree cover that is preventing us from seeing what's underneath it. So we've made a guess or we've excluded it. So that, yeah, seems to be the case. And then you update it. Got it. Got it. Thank you.
One of my pet peeves is people doing as-built are not talking to people maintaining the maps, and it just doesn't happen. It should happen.
Got it. Right. Okay. Yeah. Yeah. Right. Okay. Question in the back? I think it's polygons. I mean, it's a polygon because you could fill it. Does that answer the question? That's kind of why I think it's a polygon. I think I have 1 minute left. 1 minute. Is there a last question? Yeah. Yeah. Right. Right. So the comment was, what is the value that you get out of putting that into the maps? So this goes back to sort of the point I was trying to make at the very beginning, which is that the visual language that we use to show a thing actually changes the way we think about a thing. Right. So if we think that a space is a network and that's all it is, then we'll treat our environment the primary value of that environment is to get us quickly from point A to point B. But the opposite of that is if that space actually matters to our health and our well-being and our happiness and our enjoyment of a city or of a space, then maybe our map should also start to show what that's like. I think that's it. So thank you so much for coming out. What's that? Okay. All right, if you have anything else to talk to us about, I'm with Mapzen. We have a desk, table, booth right out here in the hallway. Come find us afterward. Thank you.